think I am live now. Can anyone confirm if audio and everything is fine? Like, how was your contest? Like, I plan to discuss all the four problems of today's biweekly 126 contest, lead code contest. And like, although I was able to solve all four of them, like relatively, like I think I could have performed a bit better in terms of speed, but that's fine. And like, if there are any other questions apart from the contest, I can also take them up. Okay, I will start from the first problem. First problem says find the sum of encrypted integers. You are given an array nums containing positive integers. We define a function encrypt such that encrypt x replaces every digit in x with the largest digit. For example, encrypt 523 becomes 555. Encrypt 213 becomes 333. And it says like we should return the sum of all encrypted elements. For example, 123, like it's a single digit element, so like encryption remains the same, and like at last we should print sum which would be 1, 2, and 3. And for example, in the other element, 10 becomes the maximum element here is 1, so 10 becomes 11. 21 becomes 22, max is 2, and 31 becomes 33. So we should print the sum 11 plus 22 plus 33, which is 63. So like problem A encrypted. First, we need a function which takes a number n and gives us the encrypted results. And then the next thing we can do is we can run a for loop on all of them, maintain a sum counter, and we would be able to do. The best way to do over here is like we can utilize like to string method in C++ to get all the digits, or we can use strx in Python to get all the numbers here. Like we need the number of digits. Okay, I will do both C++ and Python. I will do both C++ and Python, both of them. Encrypted form would be like this would be the code in Python. Like in C++, the other way once. Let's just move it out for now. Like this is how you would be able to do it in Python. Like I will also code C++ then. Or apart from toString, like you can also count the number of digits. Like let's just see. This will give us the number in string. This is the number of digits. And let's find the maximum character here. For this way, we would be able to find the maximum character, maximum digit. Yeah, direct sort can be the other way. Like, that's in fact a better idea. If we sort it, sort in increasing order, then maximum character would be the last character. And we can create a new string with this as a possible way. And then we can use ATOI method to complete. We can use inbuilt ATOI method to complete string to an integer again. And that would be the way to do it. 1 second. ATUI or STUI is the method. Okay, string to int STUI is the method. There are other ways to do it as well. Like if you are not aware of this method, then what you can do is like you can keep dividing a number by 10 to count the number of digits. And when you are dividing by 10, you can also look at the remainder by 10 to get all the digits. So for example, you have 121. Let me show you. So for example, you had, let's say, 3215 as a number. Then how can you find the last number here? Last number would be 3215. Reminder when you divide by 10, 5. And like, and you can, if you again divide it by 10, like you will get the prefix here. Integer division we are assuming, ignoring whatever is after decimal. Then you can again get the last digit by reminder 10, and then you can again divide by 10. And you can keep doing it as long as the number is greater than 0. Like that's how I did it in the contest too. Digit count, let's start with 0. Max digit, we can assign it with 0. Like this gives us the smallest digit. And now we can remove the smallest digit again. Now when we want encrypted n, we can again like take a number, we can multiply it by 10 and add one more digit to get whatever number we want. Like I plan to go in the problems in the order. Wait, what? Like, do you see an issue in this problem? Okay, less than equal. So like this pretty much complete the ideas I had. Any questions on this one before we move to the next problem? Yes, Ronak, we can also do it that way. Like there were like two ideas. One was completely iterative, finding everything from hand by running two for loops, dividing by 10, multiplying by 10. And the other way was to use built-in function. So you can also use a combination of both of them. Do one way from the first part. Like there are two parts to it. Find the max digit and number of digits, and find the number with that as a max digit. So there are two ways to do both of them, and you can mix them as however you want. So the next problem says mark elements on A by performing queries. You are given a zero index array nums of size n consists of positive integers. You are also given a 2D array queries of size m, where query I denotes index I and ki. Initially, all the elements are unmarked. You need to apply m queries on the array in this order. Where the ith query, you do the following. Mark the element as index I if you are not already marked. Then mark ki unmarked element in the array with smallest values. Here, if it's you should do it only if it's unmarked. And if multiple such elements exist, mark the ones with the smallest index. And if less than ki unmarked element exists, then mark all of them. And then we have to return an array of size m where answer is sum of unmarked element in the array after the ith query. And like let's look at the sample first. Like in the sample, it says like given arrays 1, 2, 2, 1, 2, 3, 1. And the queries are 1, 2, and 3, 3, and then 4, 2. So like at first, like when you are doing the first query, you should first mark the first element. Notice that it is zero index, which is given in the problem. Like it was not explicitly mentioned here, but like constraints suggest that it was zero index. So first thing we do is we mark the first index, which is 1. And then we mark two more elements which have the smallest values. Okay, one second. The first index is this one. And then we mark two more elements with the same index. And if you notice, like the smallest element is 1. And in case there are multiple smallest element, which you should choose the one with as the smallest index over here. So now if I want to mark two more, like these two elements would be the one I will mark. And now if I count the sum of elements which are not marked, which would be 2, the unmarked element is 2, 2, 3, and 1, which would be 8. Now the next problem says we should first mark the third index 0, 1, 2, and 3. You see that we have already marked it. So we should ignore it. And now we should also pick the smallest 3 element, which in this case, the first smallest element would be 1, then 2, then 2. And now if we count the sum, we will get 3 as the remaining, like 3 is the only element. And after it says, like, you should mark the fourth element for the third query 0, 1, 2, 3, 4. 4 is already marked. And then it asks us to mark the smallest 2 element. But you can see, like, we have only one remaining element. In that case, we should simply mark it. And like the sum of elements remaining after it would be 0. So like notice, like, you have a priority order in which you should mark elements in the second way, which would be pick smallest, and if equal, pick smallest index. And once you see it like this, the way we can do is we can put all the elements in a priority queue. That way we would be able to pop first k elements of the priority queue. Like the only problem here is does not supports deleting random elements. So like deleting the ith index would be a problem for us. So what we can do is, like, we can also maintain a vector, Boolean vector, which says marked of size n, which says an element is marked or not. So like we will treat this vector as a source of truth. And whenever we pop an element from the vector, and if this vector says like we have already marked it, then we will ignore that popping that element over there. And like pretty much that was the idea I had. And like I will show like how to code this one. Like one thing to notice, like the default order in priority queue is a max priority queue. So we need something to find the smallest element as well. Like I first define a pair of integers using II. Like I will use the acronym II going forward. Like this is max priority queue. So we need something for min priority queue. The idea is like if you pass on a method, greater is a method defined in C++ SU. So if you pass on like this, like now this is a min priority queue. One second. We should also find a method which is defined as answer. That's fine. RIO RITY. Like this is fine, right? We also need a type where you can show. Okay, this is a problem. This works, right? Yes, this works. Yeah. We also need like, so first we should find the sum of all the elements. We also define a method mark index, which will mark. Okay, how can I maintain min index? Like if in priority queue, if I put two elements, like the value and the index, then my type, if the value is equal, then the type break would be based on the index second pair. Like that's why I am using a pair here instead of a single element index. If I put a pair in priority queue, first element is the value and second element is the index, then the element comparison happens via first the dot first is compared first. If it's equal, then the dot second is compared. So if I define a min priority queue on pair, then like first the smallest value will be picked, and if smallest multiple smallest, then the smallest index will be picked. And like that was the idea I had. So like first I took some, like now I put all the element along with their index in priority queue. Now I also need a vector of marked size. If is marked, if current index is not marked, then I should mark this index. Like this element will also reduce the value of sum as well. And now I should also remove k elements. Is less than k. And priority queue is also not empty. Because when priority queue empty, we should break here. And after, let's say I have removed the smallest element, I should also insert sum here. Like this is the smallest index. Now I should remove it from queue. If this has already been marked, I ignore this part. Otherwise, I increase remove count by 1, and I call the mark index method with. And this pretty much completes the code I had for this product. 1 second. So, like, any questions on this one before we move to the third problem of today? Okay, why you have used greater? Because like default priority queue in C++ is max priority queue. So like it's slightly confusing, but that's how like the C++ standard is defined. Like using greater T would cause the smallest element to appear at the top. But like that's what. And pretty much that was the reason. And like I will move to problem C then. Like replace question mark and string to minimize its value. You are given a string S. SI is either lowercase English letter or a question mark. For a string T having length M containing only lowercase English letters, we define cost I for an index I as the number of characters equal to TR that appear before it. That is in range 0 to I minus 1. The value T is the cost of is sum of cost I for all index I. Yes, Ronak, you are right for the second problem. For example, for the string T A B, the cost 0 is 0, cost 1 is 1, cost 2 is 0. Hence, the value of cost AAB is 0 plus 1 plus 0. Your task is to replace all the occurrence of question mark in S with any lowercase letter so that the value of S is minimized. And it also says return a string denoting the modified string with replace question mark. If there are multiple string with minimum value, return the lexicographically smallest one. Like let's first see like what is the problem statement asking us. So like problem statement defines two things. One is cost given as string S. Cost of I is defined as number of characters in 0 to I minus 1 that are equal to Si. And once we have defined the cost, it says value of S is defined as sum of cost of I for all I is which is greater than 0 and less than n, where n is the length of string S. And what it asks us is like we are given some string, let's say a question mark, A, B, C question mark. So we should replace question mark with some characters such that the resulting string is minimum possible value we can get. Like there can be multiple ways to mark it. Like for example, we replace A here, we replace C, D here, we replace Z, Y here. Like any possible way. Like if there are 5 question mark, then each position has 26 different ways. So the number of ways would be 26 to the power 5. So among all the possible string we can get by replacing question mark with some character, we should pick the one with minimum cost. And if there are multiple string with minimum cost, then you should pick the one lexicographically smallest. Lexicographically smallest means dictionary order. And essentially, that is the problem. Any questions on the problem statement first before we try to solve this problem? Okay, once we know the problem statement, like one critical observation was, like let's say we have some string and that string contains 5 here. Like Like let's just start with 4A. Like star are the character other than A. Like there can be some other string as well. One, two, three, four. There can be some other way as well. Like star denotes any character other than A. Then what you can do, see is like the first character will contribute 0 to some, second character will contribute 1, third character will contribute 2, and the fourth character will contribute 3. Because like before the first character, there is only one character which is equal to it. So like as long as like the string contains 4 is, the cost of all those indexes would be 0 plus 1 plus 2 plus 3, which would be 6. Sum of first four smallest elements starting from 0. It does not matter where the A is. So like let's ignore the original given string. If we know the frequency of count of all the numbers, CZ, then like the cost value would be and so on. Like for cost, like the sum of first and smallest number we know is like it would be CA into CA minus 1 by 2. Sum of elements up to CA minus 1. And overall the value would be, and you notice like this doesn't really depend on like where what is present there. Like any questions on this one, like why like the overall cost depends only on the count of all the elements, and it does not depends on like where the how the elements are placed there or what is their order. And like now once like if we know this, like let's say we have some string, some question mark, some a. Right now there are 4 A's in the given string. Explain with one example. Sure. This is one string which contains 2A, 3B. This is another string which contains 2A, 3B. This is one more string which contains 2A, 3B. This is one more string which contains 3A, 2B. Now if I look at the cost here, number of elements here would be 0, 1, 0, 1, 2. Here the cost of this index would be 0, 0, 1. Like for this, nothing is before it. For this, this is before it. For this be nothing is before it. For this be this is before it. And for this bit, like 2 elements are before it. So here the cost is 4. For second string, for this is before it. For this is before it. And for this, like 2 B's are before it. The cost is again 4. No, like right now I am looking at the string which does not have any question mark. Like basically, like what is the cost if we look at a string which does not contain any question mark, not replacing anything? Given a string which does not contain any question mark, how do we find the cost for it? Like, because these insights will help us deciding which number should we replace at the question mark at last. And now if we look at this string, the cost here would be 0, 1, 0, 1, 2. Nothing before it. This string has these two one. This A has this one. This B has these two index. And the cost is again 4 here. And similarly, if we look at it, this string, the cost will again be 4 here. And like if you want to find the sum of first k numbers smaller, like 4 is 10, which is also equal to 5 into 4 by 2. Like this is a formula, like sum of elements up to like sum of elements up to 1 to m is m into m plus 1 by 2. And if we want to find the sum of all the elements of 1 up to fa minus 1, we can put m over here and our formula will become fa minus 1 into fa by 2. So like the way you look at it is like if there are 5 A's, then the place where the first A would be there, it will contribute 0. The place where second A would be there, it will contribute 1. The place where fourth A is there, it will contribute 3 to the answer. And so on. And now like if we have a string which contains 5A, like there, let's say there are 2A here. There can be other characters. There is a question mark. And there are 3 A's here. Then when you replace question mark with A, your overall cost increases by 5. How? Like when you insert at second index, the cost here becomes 0. Here the initial cost was 3, which becomes 4. Here the initial cost was, like let's first look at what the initial cost of each index was. 0, 1, 2, 3, 4. And after you add 1 A at the place of question mark, at second position, that it will add 2. It will change this 2 to 3. This will change this 3 to 4, and this will change this 4 to 5. So overall 5 was added to it. And you can see like it doesn't really matter at which index you added, like the 5 would be added at some place. And or you can try to like if you add the first index, then the original cost was 0, 1. And new cost, this index will have 1. This 1 will become 2. This 2 will become 3. This 3 will become 4. And this 4 will become 5. Overall 15, earlier it was 10. Like, does it make sense? Like, why we only need the count of all elements? Because if we know the count of all element, then we can directly count, like we don't need the individual cost for each index. Like we can directly count if A appears 5 times, we need sum of 0 to 4. If A appears 10 times, we need sum of 0 to 9. So for example, if we increase A by 1, then the number of A, if they were initially 9, and now if there are 10, earlier we were taking sum of 0 to 8, now we are taking sum of 0 to 9. Like, does this make some sense, or like should I probably take one more example? Like the idea is like we only need the count of each element. Now, once we know the count of all the elements, and we know that if we replace question mark with an element that appears 5 times, then that will increase cost by 5, right? With A, where FA was the count of numbers before replacing it with the question mark. Or if we replace it with, let's say, character D, then if there were FD number of D's before it, then replacing question mark by D will increase cost by FD, right? Because earlier, if we were adding 0, 1, 2 to the answer, if the number of D's were 3, then after adding one more, now we will add this to the final cost. Like once we come up with this observation, we can now find like, now we can use the greedy idea. Intent count of all characters and count number of question marks. Then we run a for loop. We find the element which appears smallest number of times. And if there are multiple elements, we pick the smallest character and then we increase its count by 1 and we can put it into the loop which we want. Like now our algorithm is like right now I'm not caring about the dictionary order. What I care about is like what should be my final set over here. And the final set's idea is like I pick the smallest, the number which appears smallest number of times. And if there are multiple such numbers, then I pick the smallest character. And I say that this would be one character which I will replace with one question mark. It can be anywhere, but that would be the first thing I will do. And what I can do is like I can find all the characters which I need at question mark, then I can sort them to get the dictionary order. And pretty much that was the idea for this problem. Q count is the number of question marks count that I need. This way, like after the end of this loop, I will know how many question marks are there and how many characters were there. Like let's start with an empty string that will take all the index over. Or I can do it this way. Like I take like smallest frequency here. Now, like once I find the character which has the smallest frequency, with this character, like whatever character I got with the smallest frequency, I can directly replace it, but I will not do it right now because I also need the dictionary order. So like I add a string over here. Like this way, I would be able to find like the set of all the characters which I need over here. Then because I need the dictionary order, like I sort all the elements. Like let's say like this has given me that I should add A, B, C, A, B. Then what I do is like I will replace, and like the position of question mark is 3, 4, 10, 11, 13. Then I should replace 3 with A, 4 with A, 5 with B, sorry, 10 with B, 11 with B, 12 with C. Although I don't need to sort it because I have pushed elements in the increasing order, but position of Q. Yes, this is I3 window manager. And like this is my overall algorithm for this problem. Like so wait. And I should also increase like the frequency here. Like that observation was crucial. Like we only need the count of all characters. Like if you look at my screencast, like I realized it a bit later and then rewrote a lot of code again. So like any questions on this problem or anything which was not clear or something that I should explain again? Like probably I might have jumped a bit faster at somewhere over there. Okay, I will move to the last problem for today then. Like if there are some doubts or something anywhere, then I can try to explain that bit faster before I move to the last problem. Okay, it says find the sum of power of all subsequences. You are given an array nums of length n and a positive integer k. The power of an array of integer is defined as number of sequences with their sum equal to k. Return the sum of power of all subsequences of nums. Since the answer may be large, return it modulo 1 in 9 plus 7. So like pretty much like a problem statement. For example, it says there are 5 sequences, number of 5 sequences of num with non-zero power. Okay, why not increasing smaller count? Like which problem probably? Here I am increasing the smaller count. Like I missed it out earlier, and that was the reason. And the way to solve this problem was like I did it the other way. Like instead of counting all the subsequences and the number of elements with sum equal to k, what I did was like I looked at all the subsequences with sum equal to k, and then I check like how many subsequences have that subsequence as a sum. Probably I will repeat again. Like what it needs is like let's say we have been given like let me just take an example only that makes it life easy. It says 1, 2, 3, and sum equal to 3 is required. Like let's list down all the subsequences here. One is empty sequence. Like these are the possible sequences for this number. And for each of them, I will have to count like how many sequences have sum equal to 3. So for example, like there is no sequence with sum equal to 3, so power here is 0. Here also nothing is there, nothing is there. In this case, 1 is there, like the only element is a sequence with sum 3. In this case, like all the elements have sum 3. Sum of all is 3, so like power is 3. In this case also like only one element with power, one sequence with sum 3 is there. And here also 1 is there. And in this case, there are two sequence with power sum 3. And overall answer is 2 plus 1 plus like all of this number, which is 6. And like a subsequence is defined as like you take a sequence, you randomly delete some elements from it and keep the order same. Whatever remains is the subsequence we need. And like once we know this, like my idea was to do it the other way. For each subsequence, of some k, count the number of like basically right what we are doing is like let's call it as a parent child. Parent is subsequence from original string, and child are the subsequences of parent with some k. And what we need is like we need the sum of children of all the parents. Like does this analogy make some sense? We have an original sequence. We have an original sequence. We randomly delete some elements from it and create a new sequence. I am calling it as a parent sequence. And from parent sequence, I am calling all the child subsequences which are subsequence of parent with the sum equal to k. And what the question is asking me is like count the number of children for each parent. And like there, although it may not happen in real life, but in this case, like a child can have multiple parents here. Like, does this make some sense, or like what the problem statement is asking us? So in this case, like 1, 2, 3 has two children. one subsequence would be 1 2 and other would be 3. While for example 1 3, like there is only one parent. And like what I need is, what I plan to do is, like instead of counting the number of children for each parent, I can also count the number of parents for each child. Like for example, let's call like C D E. There are some parents and there can be some children. Like if it's like this, then this C has two children, this D has one children, and this E has two children. Overall sum is 5. What I am doing is, like instead of counting this, I am counting how many parents is know there. Like F has only one parent, G has two parents, F has only one parent, G has two parents, and H also has two parents. So this count is also 5. Like if this makes sense, then I will move further. What I am claiming is, like let's say we have an array A1, A2, A3, A4, A5, A6, A7. And let's say sum of A2, A3, A5, A6 is K. Then how many parents does A2, A3, A4, A5 have? Like if A2, A3, A5, A6 are the children, then like the parent can have any of these nodes, like A1, A2, A3, A4, A5, A6. Parent can also have A2, A3, A5, A6 as a child. Or like A2, A3, A4, A5, A6, A7 sequence can also have a child as A2, A3, A5, A6. Or like we can in fact also include the complete sequence. This will also have a child as A2, A3, A5, A6. In fact, we can see like for any element which is not in the sequence, we have two choices for the parent. Either it is in the parent or it is not in the parent. Like there are 8 parents. Like does this make some sense? Then my idea was, like if we can somehow count DP, my then the idea was, like DP child index, child length, child sum. So for example, I have started from A1 to AIDX. My child length can be like, let's say like the children are A5, A6, A8 are the children. Then the child length would be 3 and child sum would be A5 plus A6 plus A8. The idea was whenever I am adding the last element of the child, I take sum of all elements, or I don't even need that I add, so I can take it at last. So once I am done with everything, this will denote the number of children which have I elements after I have completed processing all the elements, and their sum is k. So I should add the answer like this to my overall answer over there. And like this was the DP idea I had for this problem. Or like any confusion or like anything which I missed out on explaining on the DP states first before I jump into the code. This is the base case. I am assuming one base indexing, so I need a shift by one. Dial sum. Now I ignore. In that case, like if I am ignoring the current node, then the all the child sequence would still remain same. Or if I want to add current child sum over here, then see we should the child length should be child length minus one and C sum should be less than my current here. I can take this mod at last. And I also need powers of 2. 2 to the power 0 is 1. Like any element which is not in the child sequence can either be in parent or not. So two choices for each of them. Like here we can probably have an int overflow. So we should typecast it to the end. This was the code I had for this problem. Looks like any of the problem which you want me to explain a bit again, like I can do it. Or if there are any other question you have, like you can probably ask me. Otherwise, like I will probably end the stream and like thanks everyone for joining today. Like here, if you notice the k is up to 100, n is up to 100, but the numbers are up to 1e4. So like that was a bit misleading here. Like for good resources and yes, like a lot of people ask me, like one answer which I gave to most of the people is like you can join the Discord server where you can see roadmap to read in 2 minutes. Like the title is a clickbait, but I am trying to add like all the frequently asked questions to me there. So that would be one way. Like if you are specifically asking, like USAV guide is one which I like it. Like here it they have divided into different levels. Like bronze, silver, idea, gold, platinum was the one. Like if you look at bronze is probably for Div 3 people. Like it contains the easiest problem. Like there are some blogs on introduction to greedy. Like there are some examples and there are some sample problems which you can solve after it. Or if you move to gold, gold is probably for D1 people. Like here some digit DP, range DP, like a lot of DP ideas are there. Paths on grid, knapsack DP. Like the question is how did I came up with this DP idea? Like this is pretty much the knapsack DP idea. So like if you know how to do knapsack DP, you would have immediately realized like how to solve this problem. Like for YouTube, like you can probably search for it. Like Ericto has one. Like I think Priyan's also had one. And like Striver also has one where he goes through like all of these problems. And there would be many more. So like and like the other is yes, I am in fact creating I'm trying to create a video editorial on ad coder e problem. Like let me probably like I have prepared some of the slides for it. I can give a sneak peek of that. And like that would be the bit I would be working on after this stream. From the next time I will see like either I will do ad coder or biweekly. Like doing both of them does not looks like a justice. Or even if like first I will try to make video, like at least I will have some slide or text editorial for it. Like 1 second, let me. Means like I will have to share it with others as well. Like not a lot of people will probably look at it. Like these are the slides which I am trying to make. Problem statement, like greedy DP idea. So like I will try to. I am trying to complete it just after this stream. Like thanks everyone for joining today. Like USAV guide was there, and one more which I forgot to mention was CP handbook. These are the specific resources you should probably look at if you are starting. And like CSCS problem set is also there. So like I think this knapsack idea would be there in one of these problems. So if you would have solved these 10 problems before, you would have been able to solve today's D problem. So like that is pretty much for today. Thanks everyone for joining today. And see, like I also plan to do a lead code sync tomorrow morning. So you might want to tune in into that. If you are from India, then if you manage to wake up at 8 a.m., then yeah. Like I will say like this is knapsack DP. There is a DP word for it. Like child parent you told. Like I'm not really sure. Like I am also bad at remembering the names. But yeah, like there are like probably some name for like when if you want to find like if you look at it, there are two summations over here. First summation is for each parent, count the number with sum equal to k. So what I have done is like I have toggled those summation. For each child, count parent. And probably like double summation exchange is there. Like pretty much this is what I did. You have two summation on x and y, and you want to count something like then in fact you can even toggle this term. I will look at these summations here. Or like there are some videos over here as well. And like I came up with parent child relationship because I realized like that would be easier to explain over there. Okay, Sunday also has college. Like probably I don't really know what to say, but yeah, like I hope you have one holiday in a week. Maybe if it's not Sunday, then some other day. Because 7 days of college might be a bit hectic over there. Like in my college, it was mostly Saturday and Sunday as holiday. And sometimes if there was some festival leave in between, then teachers used to take classes on Saturdays. And you can, oh, okay, extra classes. Like you can always solve the problems after your college and look at the video if you want. So like that was pretty much it. So like any more questions or anything like, or I can call it a day today. So like thanks everyone for joining today.